Okay, cool. We're going. Okay, this week it's I called it modeling data. It's kind of like we would have been using the calculators a lot, and I'll show you that later on this one. But we're not gonna. I tried to stay away from the calculator. Did I say computers? I meant calculators. This one we would have stuck with the calculators a lot, but I'm gonna stay away from those type of questions just because some people don't have easy access to that. So we'll make it work. But let's remember a couple of things. So here, let me pull, actually, I forgot to share my screen. There it is. Y'all seeing my stuff?
Yep.
Perfect, thank you. All right, so let us recall. Back in Algebra 1, many eons ago, I'm just kidding, a couple years ago, we did regression models. Okay, so it was like we had some data and we tried to see what kind of correlation they had. Was it a positive? Was it negative? Did they not have a correlation? Was it strong? Was it weak? Like we were just looking to see what these dots were doing. Okay, and really when we did those, there was always linear regression, right? We could draw a line and it's like there's the trend. Whereas like when it's no correlation, it's like whatever. There is no line I can draw that's like a trend line. Well, what we kind of do for this unit is we recognize some trend lines and some data that can't be modeled with lines, but then have to be modeled using a different function. So like these two, for example, like you wouldn't want to use a linear function to model these guys because they're kind of curved, you don't want to, something else could fit it better. So like this one, like a quadratic absolutely could go right here and like be a pretty good model, it follows pretty well. This one, I mean, it could be linear. You could go, oh, boom, linear. But see, it's missing this like curve part right here. So instead, if we made it into an exponential model, it would fit much better. Okay, so that's kind of the idea. Man, I'm bad at drawing. Okay, I'm trying to get better. That's one of the things I'm working on. This break. Okay, so like I said, we'd use the calculators a lot. If we were in class together and we were doing that kind of stuff, we'd be using the calculators a lot. Like we'd be getting data and then we'd be like, oh, hey, that looks pretty linear. So then we'd do the linreg and get the equation for it, make predictions, all that kind of stuff. Like this one. If we had, say, if we had, see, and then I've even got, this is from the packet, but it's got instructions on the calculator, which we know how to do. We've done that all year. But we're not going to do that. But then here, like this one, like this one's like an exponential model. You can use the calculator to help you make predictions, get the regression equation, all that stuff. Same with quadratic down here. But again, we're kind of just skimming over that because, hey, we may not have a calculator, and that's okay. Now, here we go. Now we're getting into some real stuff. We need to be able to do a couple things, okay? We need to be able to do a couple things. We need to be able to, and this is what we can do without the calculators. We need to be able to say, looking at some data like this, we need to be able to say what type of a function it goes with it. So like this one, and it says it on here, but actually does it? Ooh, it doesn't. What type of function would this data fit? Like what would this type of function be right here? You get anybody?
Exponential.
Exponential, absolutely, okay? So being able to identify that function, that's a key. That's something we need to be able to do. The next thing that we need to be able to do is make predictions, okay? Making predictions from that data, all right? And we can do that using either the function or the graph. I like using the graph better. I mean, it's less precise, but I feel like it's a lot more clear. So like this one, the example that they say, it says predict the approximate number of bacteria colonies after 3.5 hours, okay? So a couple things we got to do is we got to match hours with hours, right? They gave us 3.5 hours. Well, hours is down here on the X, so we need to be able to look in the right place. So 3.5 for X would be in between 3 and 4, which was right here. And then they went, okay, where does the graph touch? Okay, right there. What's that Y value that went with it? They estimated 150, so that's how they got the 150. Okay, that was the Y right there. This was the X. So it's kind of that same thing we've been building on all year. Like, what did they give us? And then what are we looking for? Okay, in this case, with this particular model, they gave us hours, which was X. So we went to that X value and then found the Y that went with it. Okay, so that's kind of the idea. So we need to be able to tell, again, what type of function this is from looking at the data, and then be able to make predictions. Those are the two big things that we need to be able to do. All right. I'm going to skip that one. I'm also going to skip that one because that's all about calculator stuff. And let's just jump right into some of these types of questions that we'll see on our assignment this week. So right here, what do y'all think? Just shout it out. Number one, which type of function best models the data shown on this scatter plot right here? What do y'all think? We got like linear, quadratic. Absolutely. Quadratic. All right, you guys are on it. See, yeah, right there. You can kind of make that U shape, but upside down, right? So that's a quadratic. So
just like Bizarro.
Quad, exactly, right? It's like upside down. Okay. It's really, really hitting me this week, and I'm sorry to do this in the middle of the video that I'm making. I really miss you guys. Like I miss actually teaching you guys. Okay. Okay, sorry, I was getting a little emotional. All right.
I miss actually learning, but not like, you know.
You miss what, Kelly?
I say I miss like actually learning, but not waking up early.
I feel that. Well, and then when we're together, we always, we find that time to like kind of talk about non-math stuff too. And I feel like we're missing.
I'm not even gonna say it because you're gonna use it against me.
Okay.
We'll be okay, Eli.
No, he's gonna try and use anything against me.
Oh, Eli. All right.
We'll be okay, Eli. Don't worry.
It'll be great. Sorry, I had a moment there. All right, let's do number 2. Table below shows the volume of water storage tank over time. Okay, a lot of time is x. Okay, we stick with x and y, usually going left and right. Use a graphing calculator to look at the data or sketch the points on the grid below. Okay, a lot of you guys, we're not going to be able to look at the graphing calculator or use it because you may not have one, or having access to one won't be that great. So scatter plots are going to be your friend. So x and then y here. So 112 would be like this.
Well, y is up there and the x on a down, like the right.
Absolutely. Okay. So let's see, 2, 6 would be like there. These scatter plots don't have to be perfect. Okay, that's the one thing I want y'all to know. That was 6.1, but I put it on just 6. I mean, it's close enough. Let's see, 4, 1.6 would be like that, and then 5.8, something like that. So A, what type of function do you think that is?
Exponential.
Exponential, yeah. Usually those exponentials go like flat and then up like this. This guy's doing the opposite. He's starting off all steep and then gets flat like this. But yeah, it's
pretty opposite.
Still an expo. Yeah, we're sticking with that Bizarro world, huh?
Yep.
Okay. So now let's try to make a prediction. Okay, let's try to make a prediction. I did not graph that very well at all. My line sucks. But if we were to make a prediction, predict the volume of the tank at 6 weeks. Okay, 6 weeks is the X, right? X was weeks. So we go to 6 weeks right here. What's the Y value that's there? Using our little model that I just drew right there. What do you think?
I think it's 0 or something.
It'd be pretty close to 0. Remember, exponentials don't quite hit 0, right? It's got that asymptote, but it'd be really close to 0. So I would say 0. Okay, it's close enough, right? That Y value right here, it's like practically on the Y-axis or the X-axis. So yeah, 0 is probably close enough. And think about it. It's a situation. It's a thing. Like if you're draining water from a tank, it starts off with a lot, and then there's less, and then there's less, and then there's less, and then there's less, and then there's less. If you keep going, there's eventually not going to be any water in the tank. So yeah, 0 is probably a pretty good prediction. So that's another thing you can kind of do. You can kind of think about these like logically. It's a situation. It's got to fit the real world.
Yep.
Okay. All right. Let's look at this. Professor uses a video camera to record the motion of an object falling from a height of 250 meters. Here's the function. It can represent the approximate height of the object off the ground after X seconds. Which of the following is the best estimate for the amount of time elapsed when the object is 120 meters off the ground? So we got to be able to do this. Okay, we got our model. They already did it for us. We need to be able to do this. We need to be able to recognize, did they give us X or Y?
Hmm.
What do you think? This 120 meters, did they give us X or Y?
Yeah.
They gave you
Well,
Y.
come zoom at the graph.
I gave you Y
Jamie, how do you know that it's Y?
because like it's giving you like 120 meters, so it's not like I know it's Y. I don't know why.
No, you're right. No, absolutely, Jamie, you're right. You see, you're on it. Meters, right? Meters,
Yeah.
the Y is height in meters. So meters match
Yeah.
with meters. So that's why this is the Y, right? They gave us the Y right here.
That's
Okay?
a Y, and the second is X.
We need to
Second.
look for the X seconds, all right? So 120 meters, we look on our graph here. It's a little small, but 120 is right here. So I can look and see where that runs into our graph. Right about there.
5 seconds.
Looks
5
looking
seconds.
like it's a little above 5 seconds, but again, this is about a best estimate, right? So the closest one would be B, 5 seconds, right? That's 5 seconds right there. All
Good
right?
job, Jamie.
Yeah, excellent.
Good
You guys
job.
are on it. Okay.
Yeah.
So
Mhm.
that's kind of the idea. All right. Let's continue. All right. All right. So number 4, this one's a little different. Table below shows the profit based on the price for an object sold by a company. Okay. It says if you don't have a graphing calculator, you may input the point into the graph. All right. So let's go ahead and do that since that's what they've got. So 0, 4,000 would be here. Okay. Let's see. What is that? 10, 1250, 10, and then 1250 would be just about like that. 20, 24, let's see, 30, 32, 5 would be up here. Ooh, looks like we're getting off the charts here. 40 and then 36. Okay. And then 50. Oh, never mind. We're not off the charts. 53, 35. So that would be like here. I don't know, something like that. Man, I was really feeling linear. I was really feeling linear.
That's a quadratic.
Yeah, but then that turn, that curve right there, that flipped, right? That's got to be a curve. That's got to be a quad, right? Got to be a quad. It was like linear up until about here, and then I was like, oh, it kind of. And then we got that last one. It was like, oh yeah, we turned the corner. That's definitely a quad. Okay, so it's definitely gonna be like kind of quad model. So let's see. Which statement is true, or which statements are true? Oh, check all that apply. Ooh, this is a different type of question. It's not just going to be one. Maybe there's more. The data is best represented by an exponential model.
No.
Nope. We can get rid of that one.
No.
The data is best represented by a quad model. Absolutely.
Mm-hmm.
Yup. Okay. How about this one? If the price is $5 per unit, the expected profit is approximately $4,600. So let's see. Price. Oh, I think they messed this. They messed this up. I just noticed. These are supposed to be flip-flopped. Price per unit is supposed to be the X. These are the X. These ones are the Y. So this should be.
Either way, it's wrong because it's not at 4,646.
No, I know. I'm not. Yeah. So I'm gonna say that question's wrong, anyways. But this should be profit over here, right? Because these are the big numbers. Big numbers on the Y. Little numbers, those ones are on the X. So I think they flipped those around. So let's just do that real quick. All right. But $5 per unit would be right here. It should be like 12,000. So no, that's a bad prediction. Let's see. If the price is $80 per unit, the expected profit is negative. See, this is where it's like counting on you having the model, because then you'd have, you'd be able to go past here to like 80, wherever this is. This isn't the type of question I'd put on your assignment, this part right here, because we can't tell. We have no idea. I'm just going to go ahead and say it's not the answer, but we have no idea with the amount of data that we have. So I did my best to get rid of those types of questions. As the price per unit increases, the profit increases indefinitely.
No.
Well, yeah, we know that can't be true because the profit went down
Yeah.
between these two, right? That went
Mhm.
down. That was negative. So no,
Mhm.
looks like all we got is just B on that one, right? Or at least this one we don't know. That's a big old question mark right there. Not enough info. All right. Well, if we were in class with our calculators, we'd be able to do it. But oh well. Okay, let me look at this next one really quick. Yeah, let's do one more. I think. Yeah, let's do one more. Actually, you know what? No, these last two are good too. Let's just do them all. Might as well. We got time. All right. Again, I'm gonna just go ahead and plot these. Let's see, 0 to 25, something like that. Yeah. 118. Let's see, 214. 310. 50. Okay, so there's our scatter plot there. Let's see if we can do this. What A and B are talking about which model. If you had to pick between exponential or quadratic, what would you guys
It's
pick?
exponential.
Interesting. Yeah.
This look like negative, right?
Yeah, it
Right,
looks kind of
negative,
like
yeah.
it looks like kind of one of those negative exponentials, like where it gets smaller. Yeah, it doesn't like have that like turnaround point like a quadratic, right, where it like switches directions, but it definitely is not linear. It's definitely doing this kind of like curve thing.
Wait, so this is probably the quadratic graph. That's a positive too. That's a positive one, right?
For the quadratic,
Yeah, that's positive, right?
this one would be a negative quadratic just because it's like flipped. Like the arrows aren't going up, they're going down. So we'd consider it to be a negative one. Same with like this one. It's technically not like a negative one, but it's going down. So we call it, that's why we've been, throughout the year, we're like, oh, this is the negative one because it's coming down.
Okay.
But okay, so exponential model, absolutely not a quadratic model. The function decreases indefinitely. What do y'all think of that statement?
That sounds kind of true a little bit.
Like, so what that's saying, that's a fancy way of saying this function is going down forever.
I mean, it is going down. I mean,
Yeah, it's going down. But then remember, exponentials, they kind of flatten out, but they always are getting smaller. It's kind of a tricky question. It's true, actually.
yeah, it is.
It goes down forever. I mean, it doesn't go down by very much once it gets pretty flat, but it's still technically going down. So yeah, it does decrease indefinitely, or it goes down forever. Let's see. It is reasonable to interpolate. That's a fun word. To the value of the car at 4.5 years. So
What are
basically,
extrapolating?
what this means is like it's basically saying like with your model, is it like reasonable to use that particular point on your model, like for a prediction? So is it reasonable to interpolate the value of the car at 4.5 years? Well, 4.5 years is right here, and we have data in between that. So yes, it is reasonable, absolutely, for D, because this is within our data set right here. Like if we were trying to make a prediction at 4.5, we could do it. And it would be cool because it's within our data set. But then the question is, if we took this out to 40 years for the next one, is it reasonable to take this model out to, 8, 9, ... all the way to 40? Do you think this model would be a good predictor at 40 years?
No.
Yeah, I don't think
No.
so. I don't think so either. I agree with that because like 40 years, that's a long time. Like this is just looking at it over 5 years. If we were maybe saying like, let's use our model to predict like 6 years or 7 years. Absolutely. I'd say perfectly reasonable. This one, 40 years, that's a long time. Like that's out there. So I'd say no on that one. Okay. So that's kind of the idea with that type of question too. So that's some good vocab in here. All right. Oh, last page. Okay. This time they've got our regression model already plotted for us. They've got all this stuff. All we're doing is making a prediction. What is the estimated population after 25 years? Again, we need to be able to check what they gave us. Did they give us X? Did they give us Y? What do y'all think?
X. Well, year is an X, and the population is a Y.
Absolutely. So they gave us X is 25. So go down here to X is 25. Go touch our graph right there. Let's see. What's that Y value there? That is
11,000 or something.
it's 100. Wait,
100.
110,000.
10,000.
They didn't have the little commas there. That's what makes it hard. 110,000.
10,000.
Okay.
Ooh, that's a lot.
That is a lot of people.
People. Ooh.
All right. So that's the idea, okay? That's the idea with that type of question. This one's dying on me.
Yeah.
Switching pins. All right. Last one here. Oh, I almost gave away the answers. Okay. So we got another one here. Okay. Time and height. Again, what is the estimated height after 0.25 seconds? Again, we got to be able to recognize what did they give us?
Oh, well, time is a X and the Y is high.
Perfect.
100.
So X is what they gave us. Y is what we're looking for. So remember, that's 0.25 seconds.
Oh, no.
Okay.
Oh,
It's
goodness.
100.
Might be hard to see. 0.25 would be here. Okay. So let's look at our scale here. Let me zoom in. This one's tricky. 0.25 is half of a half. It's a quarter of a second. So this right here would be 0.5, right? That'd be half of the second, right? There's 1 second, so that'd be 0.5. So 0.25 would be this guy right here. Be that guy right there. Okay. That's why this one was a little tricky. So it's actually 20.
20.
That guy right there was 20.
20 high.
That'd be 20 feet.
Feet. Yep.
Okay.
Mm-hmm.
So that's where that one was a little tricky. That was 0.25. And then, man, my
Mhm.
printer did not do a very good job because that's 0.5. And see how this one was 2.5? Yeah, see that. I see where y'all got 100. I'm sorry. This thing, my printer was giving up on me. I see that now. Okay, so 0.25 would be like in here, okay? In between the 0 and the 0.5. All right, so that's the idea. That's what we got. Any questions about this stuff before I stop recording?
Well, that was easy.
How about like a reading one?
Reading one?
Yeah, like it's asking which is it exponential, linear, quadratic, by like reading it.
Oh, like by like just reading the like situation, like so you don't have the data like this.
Yeah.
Like let's say we didn't have this, like
Yeah.
or the function, and you're like, oh, I need to figure out what type of equation it is, like what, like
Yeah.
if it's expo or quad or whatever.
Mm-hmm.
You won't have to do that. You won't have to do that with this stuff with just words. You'll have some kind of data set. You'll have like number 2, you'll have some kind of data set that you can graph or something like that, so you can kind of see. But you'll always have that data set. Okay, so you don't need to really worry about that. I hope. Am I lying?
Okay.
See, Kelly, it's easy. Just find the key for X and Y on it, like a bottom as a X and the Y is a top, Kelly.
Okay.
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 Hopefully I'm not lying about that. If so, you can come
He's not lying.
hopefully you can come to the tutorial or something if I am. Okay, I'm gonna go ahead and pause recording. Where's that? I lost it. Oh, there it is.
Well, God blast.
Pause. Oh no.